Hello, everybody, and welcome to our note on finding the asymptotes of rational functions. So this is something that we need to review before we can go further with our calculus. Remember that rational functions have various asymptotes, and we are going to find all of the different kinds of asymptotes in different ways. The very first step with working with rational functions is always to completely factor the polynomials. Once they're in factored form, then find all the zeros. Okay. Now, the easiest one for us to find is the vertical asymptotes. Vertical asymptotes of a rational function are found using the zeros of the denominator. Remember that a vertical asymptote is a place where the denominator can't divide by zero, or sorry, where the denominator divides by zero. So any values that make the denominator zero will give you vertical asymptotes. For a horizontal asymptote, we have these guidelines. If the degree of the numerator is greater than the degree of the denominator by more than 1, the graph has no horizontal asymptote. That'd be a situation like this, where the leading coefficient has a degree of 5 and the leading coefficient of the denominator has a degree of 3. If the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote is the ratio of the two leading coefficients. So if they have equal degrees, then they both grow at the same rate. So the top always grows 2/3 compared to the denominator. Okay. And if the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is 0. So if we have a larger degree in the denominator than the numerator, we always have a horizontal asymptote at 0. And the reason for this has to do with limits. When we're calculating horizontal asymptotes, we're actually finding the limits. We're finding the limit as x approaches infinity. So for example, when I'm doing the top one, if I had y equals 2x to the 5 over 2x cubed and a bunch of other stuff, we can imagine that as x gets really, really big, the numerator is going to grow much faster than the denominator. So we're always going to get a value. You can always take this large number and divide by this smaller number. And that's why it doesn't ever approach a particular y value, because that number is always changing. But when the degrees are the same, these are growing at relatively the same rate. If x is 100, this is 2 times 100 to the 5 over 3 times 100 to the, to the exponent 5. If it's 1,000, they're growing fast, but they're growing faster than the previous example, but at an equal rate. So it always has this relationship of 2 compared to 3. If we think about this one, as x gets really, really big, okay, so we're thinking as x approaches infinity, then the degree of the denominator is larger, so this is increasing way faster than this is. This denominator is going to get very big very fast, and when we have a small number divided by a large number, we always get a fraction that's very close to 0. That's why we always have a denominator here at y equals 0. So what we're really doing as we imagine this is we're imagining the limit as x approaches infinity. And to work with those limits as x approaches infinity, we need to factor out the largest factor of x from all terms. We're going to see that in a later example, but that's what I want you to think of. That's why these guidelines work. Okay, and last, if we're talking about oblique asymptotes, if the degree of the numerator is greater than the degree of the denominator by 1, then there's an oblique asymptote. The asymptote is the quotient numerator divided by the denominator. The quotient of the numerator, I should say. So we're going to look at a few examples of calculating asymptotes. Remember that an asymptote is an imaginary line that cannot be crossed. All rational functions have vertical asymptotes, and a rational function may also have a horizontal or an oblique asymptote, but it never has both, because if the degree of the denominator is greater by 1, it's oblique. If it's greater by more than 1, then there's no horizontal asymptote. And if it's equal to, if the degrees are equal or the denominator is greater than the numerator, then we have our horizontal asymptote situations. Okay, so we're going to take a look at several examples in our next video.